My name is Mantas. I work as a software engineer for a company called Uber. I don't know if you know this company. There are a lot of first times here in Budapest, actually. That's my first time in Hungary, first time in Budapest. First time I did my slides using Present. Do you know this all? Yeah. So, okay, here we go. Today my topic is measure everything, not anything. So I will talk a lot about metrics, and in case you don't know what metric is, it's very briefly everything you can put in form like some name, value, timestamp. In very short form, it could be much more complicated. So that would be named metric. And it happens, I really love metrics. Actually, my love with metrics started like 4 or 5 years ago. The reasons I like metrics. Metrics is knowing, metrics is visibility, metrics gives confidence. You can improve when you know and when you see, and metrics gives predictability. Of course, some people say like, why you should know, right? Because not knowing is a pretty powerful strategy in your life, right? So, what it happens, I do love those. Metrics can start, actually, do you know this guy? He's like Lance Armstrong. And there's Lance Armstrong bug. And Lance Armstrong bug is when you do know it exists in your code or whatever, but you can't prove it, right? So metrics could help you solve this problem as well. Right? Metrics sometimes shows me some signs. I'm aware of that, but I still love those. That I even wrote an article, metrics-driven development. It's like test-driven development, just not that. On InfoQ, I still feel the pain after I did this. So today I will talk like we still need like to measure everything. I'm not moving from that way. I will talk what we do at Uber to collect metrics, how we do that, what tools we trying to use, and where we are moving, and not anything. Right? That you don't need actually to measure anything. So measure everything. As I said, like those key reasons, we were talking like there were many presentations explaining why you need to do this, but many those like as I mentioned, visibility, opportunity to improve on something. Many of those reasons, right? And metrics-driven development, all this article was about like to make, actually I could make it was on this slide to measure everything. It's like, make metrics actually full, like, citizen of your code. It's like part of your coding practice, right? It's not something like you write the code, put it in production, and then, well, is it used? How much requests per second do I have? It's not something you do after you push your code in production. It's actually what you do during whole development cycle, right? Other thing which is I found is important, and then sometimes it's misleading because it's easiest to actually to do vice versa. It's easiest to start measuring, for example, how much CPU I'm using, how much memory I'm using. But those metrics could be actually least important. The most important metrics actually is business metrics. And if you don't know what's business metrics, for example, business metrics, right? So get a guy in the company which titles start with some C and something and ask him. And I'm sure he will tell you what's his business metrics, right? There is application and services metrics. How often my application is used. Is it used at all? How fast it is? It is like getting faster or slower when I release new generation of it. And only that, and I can put some metrics right on the infrastructure, CPU, memory, disk, network. Other thing, when you do measure, make it visible. It's not only for you, right? You need to show for everyone actually in the company how it's being used. one of the greatest cases I saw, it's like team put some screens on the wall, and actually they're able to count the money they bring to the company every second. So it was pretty great. So if they release a bug in the code, they see the outage and they say, oh shit, we lost like 100,000 euros, right? So no parties tonight. So this is really great examples how it could be used. So it's not only for developers, for operation people, but it's really even for business people, product owners, and all of those. Other thing, measure frequency. Average is not enough. Please use percentiles. I saw cases when measurement is done like every 5 minutes. It doesn't tell you anything. Actually, it's better not to do that at all. I saw even when measurement is done every second, but there's so many requests per second that if you take average for 1 second, you will get really good result. But what was behind that, it's like 20% still requests still was failing. So percentiles, it's like 15, 17, 5, 95, 99 percentiles, which will give you a lot better perspective into what's happening actually with you. Instrument code. There are like lots of libraries. I don't know what languages are you using here, but there's really like StatsD libraries for literally every coding language I know, and make it self-service. Like it used to be operations battlefield. Please make metrics, right? Developers could push the code in production, and then operations guy, please see how we're doing, right? It's not like this, right? You need to talk like with development guys, and then make them like. It shouldn't be like I put the code in production and then I need to go to talk to some kind of guy named Steve, and Steve, please do something that I will see something, right? So it should be like really self-service. Everyone could instrument it. And it's not basically about configuration metrics, but it's like really good practice. Even if you have one server, even if you have one application, please use configuration management. If you're old, as I am, please use Puppet and Chef. If you are like a lot younger and then passionate, use Sal, Ansible. Yeah, but it doesn't matter actually. Pick tool what you like, and just please use, and put that code under version control. It will give you lots of benefits. If it's not straight away, if you leave the company or something will happen, everyone will know what was done, when done, why done, right? Okay, so this is on measuring everything. So as I told, I work for Uber. Uber is was founded like 5 years ago. It's a pretty new company. We do 2 to 3 million trips daily around the world. This information, it's a bit like 3-4 months old, so it could be changes we are working in 329 cities around the world, 64 countries and 6 continents. We're not in Antarctica, but I think there is some goal to move there. Over 4,500 employees spread across the globe. From those, there's some 1,000 and maybe 200, 300 engineers actually working in Uber. Our headquarters in San Francisco. Myself, I'm located in Vilnius, Lithuania office. We have like 15 engineers in there. I'm only one working in observability team. Observability team, it's that team which actually provides a metric solution for Uber as a service for all the rest of the guys. The main group of the team, actually almost all located in New York. I'm just sitting here in Vilnius. Uber is very metrics-driven company, right? Metrics treated super seriously at Uber. Nothing will happen if metrics won't work. We already experienced that. Everything will come. this is first implementation. Actually, I wasn't there in Uber, but this is first implementation of our metric system. It's pretty sophisticated, right? And can you guess how old it was? Like how long ago we had this? We had this.
Last year.
We had this like 2 years ago. 2 years ago, everything was on one server, one graphite server. Everything was collected in there. Everything was fine. Everything was working. People didn't have any problems, right? So that was good times. But then it happened that number of metrics actually exploded, and it happened like and exploded. It's like in many hundreds of times. And the reasons of why it happened, because it's easy to onboard, right? To Graphite, you just send metrics and it shows up, right? Engineers team, it's like getting bigger and bigger and bigger. When I joined Uber, actually a bit more than a year ago, we had like 300 engineers, 350. Now it's 1,300. So it's grown pretty fast. Globally distributed, actually. If you deploy your application like for one city, it's your same application for another city, right? So your number of metrics actually duplicates, and you have like 300 more cities. So the number of metrics actually keeps increasing. And the final but not least, it's like microservices, right? God. You used to have like one application, it was working, right? Good. When microservices started, right? You collect this still same amount of metrics from every server. So if you have like 10 of them, you still collect like 10x. If you have like 300x, suddenly your number of metrics really increased. And I couldn't present a diagram of our microservices, but this is a diagram from Netflix, right? I show you ours doesn't look much worse actually. So this is like lots of services, right? For each we need to collect a bunch of metrics. So it happened that this number we collected really increased. So we already went through different iterations for Graphite, and this was last implementation actually for it. I don't know if you see it. Pretty big screen. We're using StatsD. StatsIte actually see implementation of StatsD. What's interesting, actually, we're using a local agent on each server to collect metrics, and we're not doing actually at the time we do aggregation, but it's a bit of buffering, because if we're not buffering, actually we're flooding all the network and everything crashes. Then we collect in StatsD. StatsD sends into Graphite. We use consistent hash actually when we send metrics. And we had lots of implementations, problems actually with this. It was super hard to keep running and to maintain. The problems actually, those were everywhere. Services were crashing because they were using one core, one CPU core. It wasn't enough, we needed more powerful servers. Services themselves under the load start behaving super weird. They were like cutting metrics whenever they like, and all kind of strangest problems. Actually, even if one of those servers fail, we're losing a bunch of metrics. Actually, we lose this subsequent metrics range, and there is some time actually to recover, or sometimes it's not even possible to do that. So we actually thought what we should do. We could like improve Graphite, like rewrite Graphite, or choose something else. Oh, and there were some more problems I already was talking. This is some statistics actually from the last year when we moved up from Graphite. We were collecting some 50 million Whisper files. This means like 50 million different metrics, and it was ingestion in 600K updates per second. So we were thinking what to do actually, and then there were multiple options, and we were considering some of them, and we went with Cassandra as a storage. I could do actually presentation for like 2 days talking about Cassandra and how to maintain Cassandra and all that kind of stuff. and this is from Wikipedia. Cassandra is, it's not even about Cassandra as a software, but I feel that it was pretty in place here. Cassandra is figure of epic tradition and tragedy, especially tragedy. So, yeah, but we're still using it, and the reasons why we chose to use it. Cassandra is super great at writes, right? And this is important for metrics. As I said, you saw that at the time we already were ingesting like 600K per second, so, and we were growing super fast. So the write times super important for us. Cassandra is super good at that. It's incredibly good, out of the box good. Cassandra had this data compaction strategy which supported time series data. It was introduction in 2.1 version and backported to 2.0. We didn't need to delete any data. Cassandra supports CTL, data is outdated and then removed. And we looked what is on the market for Cassandra, and we found it was BlueFlat. It happened, BlueFlat was written in Rackspace, and it happened two, I think, or one. Guys who wrote BlueFlat in Rackspace, they were already working for us. So we had to speak how to do that. So that's reasons why we chose BlueFlat and to go with BlueFlat. And this is kind of an implementation that actually reflects in current implementation we do have. So we had our system, Graphite, everything working. Actually, in the day 1 or day 2, we wrote a converter and we get all the production metrics in our staging, testing cluster of BlueFlat. We roll out BlueFlat pretty fast. Actually, it was pretty simple. Wrote the converter and start ingesting everything. And it's not actually everything. Convert actually could reduce amount we ingest. We can control the amount we ingesting because, of course, we didn't have global infrastructure here. So metrics comes here. This is ingester. It ingests in Cassandra cluster. This is separate service which is rollup. It reads from Cassandra, averages metric in bigger buckets, like per minute or per 10 minutes, put in another tables or key spaces for Cassandra terms. And there's query service which you obviously get your results from. But the BlueFlat wasn't good enough for us. Actually, BlueFlat says we good, we support 1 million. Yeah, they said we support 1 million different metric names. And you saw we have already 50. And it wasn't working for us at all. It was super, super slow. So we rewrite everything. And here comes M3. Our metric server is called M3. It's from Matt Mihic Metrics. This main guy, main technical lead, he's Matt Mihic. He's working in New York. So everything is written in Go. So we ingest metrics in some kind of router service, and it says okay, so metrics goes to ingester injects into Cassandra. We don't have monolithic Cassandra cluster anymore. We have separate Cassandra clusters for separate buckets of metrics, separate types of metrics, separate time ranges of metrics. We have quite a few of them. We have aggregator which aggregates those metrics. For example, metrics comes in per 1 second or per 10 seconds intervals, but then we need to store them for 2 weeks or month, right? So we aggregate them for per minute buckets, and so aggregator does that. But how it does that? It doesn't read from Cassandra because Cassandra isn't really good. It's a lot better than it used to be, but it's still some struggling to read. So actually aggregator gets the same raw metrics, aggregates in memory, pushes it to another Cassandra cluster. Indexer, we keep metric names in Elasticsearch. We get raw metrics, indexing names, putting in Elasticsearch for query event. Query server is still the same purpose. You get metrics. One more thing to note. we tried actually to push our graphite metrics to import them to Cassandra. We wrote some tools and tried different approaches. In the best effort, it would take us like 2 months to import raw metrics. So obviously we didn't do that. So what we did, we instrument query service to query from Cassandra into Graphite. So when the query comes, it knows what time ranges it needs to get, it knows where the metric should be located, and it gets from there, or both of those places. This is a quick look into querying diagram. We're still using Graphite FEs by today. Graphite FEs, it's just running Graphite Web for functions, actually. We still implementing functions from Graphite Web. We're writing every function actually in Go as well, as we see like really huge improvement in speed, like 90 times. Yeah, so the metric, so the numbers right now, we're ingesting 1.2 million metrics per second per different clusters. That's not on one. We indexed it. I looked before doing presentation. It was like 426 million different metrics, and as you remember, it was 50 millions in the Graphite, and we store about 300 terabytes of data right now. So it's pretty big. And what we learned actually doing this, keep this like data with separate needs, just keep that separate. We tried to combine that, it didn't work. We had different kind of crashes actually because of that. Your metric system should be more reliable than systems you actually collecting metrics from. Because if guys who using your system starts not to believe in your system, is it working or not, or it will work today or not, it's some not good things start to happen. And as I said, in Uber, if metrics doesn't work, we're actually totally blind and lots of things just stop. Of course, no releases and any experimentation, everything just fails. Actually, this was interesting. We are not eat your own dog food. When we started actually with M3, we said like, okay, so what first servers we will start measuring, like start collecting metrics from, and of course it's our servers, so let's collect from our servers. And we start doing this, and suddenly we have an outage, everything stopped working, and then look at the metrics, what's happening, and there's no metrics because we stopped. So for metrics, you should figure out how you measure metric system when it's actually having the outage. In our case, we have meta monitoring, meta metrics cluster, where we collect metrics to very different cluster about our metric system. And then you can ask who monitors meta monitoring, right? So no, but the main cluster actually monitors those. Cool. So why not anything? As we were doing this and working in Uber, I happened to work with some of developers, saw some of patterns, and saw some actually abusing how they are using metrics, because I will show you some. So the problem is we using we collecting a huge amount of metrics, right? In terms of data storage, in terms of different metrics. And this very natural question to ask actually is all metrics we collect, being huge. And the answer for that is like, of course no. And why is that, right? And it's not easy to measure how much of those are used, but we're moving that. But definitely it's definitely not using every actually metrics. For operation guys, it's obvious reason, right? It's like the developer. They want to harm us. They want to do some bad things, but that's basically not true actually, right? So we don't really believe in that, right? The key reasons, to my opinion, it's good that it's easy to onboard. and it's bad that it's even good. No one thinks anymore, right? It's self-service, right? So whatever I want to do, send something, I send something. And I don't even need to think it's good or bad what I'm saying. It's, in most cases, it treated as metric system, even monitoring system, it treated as a free resource, right? I know those guys are working. I know if I send this metric, it will work. That's fine. So I will send them like 200,000 per second, and it still works. So I will double that, and it still works. So I keep doing this, right? This copy-paste pattern, right? So if I use some library and it works in some code, and I write another application, what I will do? I just copy this place, put to another application, right, on another service, and it doesn't work all the time. We saw some really strange cases when you start sending really crappy metrics. Of course, bugs happen, mistakes happen, and sometimes just not thinking. Because it's free resource. Whenever I do, everything will work, right? So, what kind of bad metrics actually I saw during my time at Uber actually? Oh, this is very. Actually, I put some of them, but there was some. There's some random number, some generating, some number. There's some IP addresses. There's some UIDs and UIDs. Or even this metric is like, it's actually metric like UID or UUID, right? What you will do with this? Nothing. You won't use it. It's not possible. And even if it's like random number or something generated number, you won't use it. You generate every time different metric, you won't use it. I saw telephone numbers, I saw names of persons, I saw license plate, I saw lots of things actually in the metrics. So that's not good approach to do that. Other thing I saw how guys are sending huge amount of metrics, like from one server and one service, one tiny piece of code, and they're sending like 300,000 per second. And to put that in perspective, actually, I listened to a presentation from GitHub, Etsy, and someone else actually in Monitorama, and they were telling some numbers, how much they are collecting. And I saw some numbers actually bigger from one of our service than combined what those three companies were collecting. So it's insane, right? You don't do anything with those kind of metrics. If you aggregate even one metric per second and you send 300,000 per second, so that means 300 data points you aggregate or whatever you do to one point. It doesn't make sense. You won't see anything. We saw like using configuration management, using Puppet a lot. And what happens, you write the Puppet code, you instrument it, like I spin up like Elasticsearch cluster, and please send all those metrics for all Elasticsearch cluster, and please send all the metrics for all my indexes in Elasticsearch cluster, right? So everything is fine. In production, you can have like a lot of like different index names, but still they're pretty like consistent and not growing super fast. Whereas in like staging or test environment, you can like create index, drop index, create index, drop index, and you still send like several thousand of metrics on each index. And that could become really bad, super bad pattern actually into doing this. Is there anything we can do about this? At least we're trying to do something about this. We try to check reads against writes, right? If you take particular metric and see how often it's written and how often it's read. And if it's not being read like, if it's not being read like for 1B, I don't think it's even worth actually to have it. We tracking numbers, each server actually emits. We list them as a list to know for us, and we check with those teams if everything is fine, if they do understand what they're doing, if they really need what they're doing. Other thing, we implemented some of the filtering in some of our pipeline, and we actually filter out like those UIDs and some other things. It's not best approach because there's some like false positives, but it works. Of course, other thing is like teaching and providing good cases examples. For example, we're using microservices a lot, right? And we can say like, if you create microservice, here's like 20 or 30 or 40 metrics you need to collect from your service. Provide tools to do that for languages you use. Provide documentation on that, examples on that, and developers pretty good on doing that, right? So it could be handy. Okay, so summary. What we learned today. Metrics are really, really important part of development stabilities, and I think the usage will grow. At Drupal we collect a lot of metrics. Not all of them we are using. We still figuring out how to deal with that, but now we collect a lot of them. And people get killed, applications get killed, services get killed if metrics being abused, right? That's it from me today. Hope it was interesting for you. I don't know how yeah? Cool. So, thank you all. I don't know if we have time for questions, or you can get me, like, I will be around here, so you can get me, we can chat about it. Okay, thank you.